Students, today we are going to discuss the wonderful phenomenon of light. It's polarization. We know light has some phenomena: interference, reflection, refraction, diffraction, and polarization. Reflection, refraction, interference, and diffraction. These three phenomena explain light is the waveform. The phenomena like reflection, refraction, interference, diffraction. These four phenomena explain light is a wave nature. It's a wave nature. Light is a wave nature. But the another one of the phenomena like a polarization. Also explain. But this is the different from these four. Reflection, refraction, interference, and diffraction phenomena, it's a common for both sound and light. Sound and light. Reflection, refraction, interference, and diffraction. These are four phenomena common for both sound and light. But last one, this is the polarization, one of the wonderful phenomena of light. It is not common for both sound and light. It is only for the light wave, not for the sound. That is why the type of wave, whether the transverse or longitudinal, there are the two type of the waves. There is a type of the waves: transverse wave and the longitudinal wave. Whether the given wave, the transverse or longitudinal, distinguished by only the polarization. Reflection, refraction, interference, and diffraction, these phenomena common for both sound and light. But only the polarization, not common. Only it is for the light wave. So the type of wave, whether longitudinal or transverse, distinguished by only the polarization phenomena. So the polarization phenomena demonstrated light wave is a transverse vibration, not longitudinal. But the sound wave is longitudinal. Reflection, refraction, interference, and diffraction. From these phenomena, we cannot distinguish whether the wave is transverse or longitudinal. Only the phenomena like polarization which distinguishes light wave is exclusively transverse vibration. So the transverse vibration demonstrated by the phenomena polarization. Okay, what is the polarization? The polarization means the restricting vibration of the light from the source. How? For example, there is one object. There is one object. If the object, suppose natural crystal like a tourmaline, a crystal like a tourmaline. For example, take this is a tourmaline crystal. If I throw this crystal, it is a transparent material. Tourmaline crystal is a transparent material. If I look for any object, throw the crystal like tourmaline, I can see the object. I can see the object. If any rotation made by me, the crystal, still this object is visible. Object is visible. If another one more crystal, suppose these are the two crystal. If this crystal, I am looking the object through this crystal, I can see the object. If I am rotating, still I can observe the object, I can see the object, still it is visible. If another one more crystal, one of the crystals are kept like this, another crystal. So these two crystals, both are made of a tourmaline, kept parallel to one another. If the crystal, this is the crystal A, it is a crystal B. If the crystal B, I am rotating slightly from 0 angle, from 0 degree. Now, the light coming from the object is traced to invisible. If I am rotating the second crystal from 0 to certain angle, now slightly the object is changing the intensity of light coming from the object. If the crystals are completely made 90 degree with A, I am unable to see the object, completely invisible. Completely invisible. Why? This is the phenomena. This is the phenomena. See, the light, if I look this a crystal, if I look the object through the crystal, if I rotate any angle by the crystal A, single crystal, still I am able to see the object. If another crystal is placed, if rotating from the certain angle, from 0 to certain angle, if the angle is increasing, is reducing the light coming from the source, or the object is unable to see. If one stage, if the crystal B made exactly 90 degree, I am unable to see the object. So completely object is invisible. Why? This is the phenomena. The phenomena is like a polarization. So restricting vibration. So the vibration from the source completely restricted, but the vibration is transmitting the only one direction. That a process, that's a phenomenon is called a polarization. For example, this is the crystal. It's a tourmaline crystal. This is the optic axis. For example, take this. My finger, this is my form. This is the crystal. The crystal, there are number of axes. That's a uni-axis. Uni-axis. If light coming from the source, see the vibration, these are the vibration. This vibration can penetrate through this. If any vibration perpendicular to the slit, completely restricted. Only the radiation parallel to the axis can pass through it. If radiation perpendicular, so this radiation parallel and perpendicular, if this radiation coming from the source, only the radiation which are parallel to the axis of the crystal can pass through. Another radiation completely restricted. Why? The light consists vibration all direction, all 360 degree. So this light coming from the source. So the vibration all direction. The way this is called unpolarized light. Or ordinary light. Light coming from the source. The vibration all direction. If the light coming from the source, the vibration all direction passes through the crystal. The vibration which are parallel to the axis, can transmit through the axis, through the crystal. The vibration which are perpendicular, completely restricted. So there would be the emergent light. Is the direction of the propagation. Of light. This is the direction of the propagation of light. This is the crystal tourmaline. This is the optic axis. It is the optic axis. Light coming from the source. So the ordinary light consists of vibration all direction. If ordinary light, so this is the ordinary light. vibration consists all direction if all the radiation resolve the two components. One is a parallel component, another one is a perpendicular component. If all the radiations resolve the parallel and perpendicular components, like this. See, this radiation of all light, the light coming from the source, the radiation consists all direction. But all direction of the radiation can be resolved into two components. One is a parallel component, another one is a perpendicular component. This vibration can be written as like this. Like this. So this vibration is called electric vector. Electric vector. This vibration, the electric vector. So the radiation can be mentioned like this because can be resolved into two components. One is a parallel component, another one is a perpendicular. All radiation, every radiation as a component. One is a parallel component, perpendicular component. Parallel component is a perpendicular component. So this is also unpolarized light. Unpolarized light. But this is the direction of the propagation. All radiation perpendicular to one another because the light wave is a transverse. If the light wave is a transverse, the electric field vector, the magnetic field vector perpendicular to the direction of the propagation. So we are considering only the electric vector, not a magnetic field vector. Electric field vector has been resolved into two components, parallel component, perpendicular. All two vectors, parallel and perpendicular, parallel component, perpendicular component. These two vectors perpendicular to the propagation, direction of the propagation of light. Direction of propagation of light. So this is the radiation, consists all direction, the vibration. So this is propagation, direction of the propagation of light. But all the radiation can be resolved only two components, only the parallel component and the perpendicular component. Okay, the radiation coming from the source. The light consists vibration all direction, passes through the crystal like a tourmaline. Naturally, the tourmaline crystal, the molecule arranged like this. Molecules are arranged like this. If radiation passes through the parallel, can penetrate. The radiation which are perpendicular, the crystal completely absorbed by the crystal of molecule. This molecule. So the radiation which are parallel, to the axis can penetrate. Only the vibration, emergent vibration. The radiation which are perpendicular components, so completely restricted by the crystal. Only the radiation parallel to the axis penetrate or emergent. But the intensity of the radiation reduce. Already it is 100%. It's already 100%. Suppose intensity is I naught. Now the I naught by 2. Only the one component, all perpendicular component of vector, emergent. But parallel component emergent, perpendicular component completely restricted by the crystal. Only the intensity, half of the intensity can be transmitting through the crystal. So this wave is called polarized light. This is called polarized light. So the restricted vibration into only one plane. That means the vibration which are parallel to the direction of the propagation, perpendicular to the direction of the propagation, parallel to the axis. So the restricted vibration is called a plane polarized light. So the half of the intensity of the light is restricted into only one plane, which consists vibration all direction, but the vibration consists only one direction. Restricted parallel to the axis, perpendicular to the direction of the propagation. So these waves said to be polarized light. It is called polarized light. If the given light is completely plane polarized or not, or the given light is a transverse, how to determine? If under one more source of a crystal, now we are placing on the direction. The crystal A, this is the crystal B. Crystal A, this is a crystal B, it is the optic axis. So the vibration passes through the crystal. What happened? Same vibration can be transmitted. Why? Parallel to the axis. There is no perpendicular. So the perpendicular vibration completely restricted. So only the parallel radiation coming from the A passes through the crystal B, emerging. This is also polarized. But if the object is placed here, I can see the object from this crystal A, but intensity may be reduced. But I can see the same object. If I can look the object through the other crystal, both the crystals are kept parallel to one another, still the object is visible, but intensity of light coming from the object is reduced. Still I am able to see the object. Why? Because the same radiation is emerging from the crystal B also. So the given light is a transverse. How to determine? If the crystal is, this is the crystal is now rotating. This is the first crystal, second crystal. Now the second crystal A, B is parallel to the crystal A. Now the crystal is rotate. Slowly I am rotating. Now the intensity of light coming from the source reduce. Intensity of light coming from the source reduce when the crystal, if the crystal B exactly perpendicular, this is the crystal B. If exactly the crystal B is exactly perpendicular to A, no vibration coming out from the B. So entire vibration restricted. If the crystal, already the crystal is like this, it's a parallel. Now the crystal is slowly rotating, the intensity of light coming from the source reduce. Once the crystal is facing exactly perpendicular to the crystal B, no light. I am unable to see the object because intensity light completely zero. But before, when the crystal is parallel to the crystal A, I can see the object. But intensity may be less. But the entire intensity light completely stopped. Intensity completely stopped. Once again the crystal, it is a parallel. Now it becomes 90. Now you can rotate from 90 to 180. Now again the crystal becomes parallel. Now the light is coming out. Intensity increases. Already the intensity decrease from maximum to no light, no intensity. Now the intensity increase from 0 to 180, 0 to 90, 90 to 180, again from 90 to 270. Now it becomes parallel. From 270 to 360 it becomes a 0 angle. See, for one complete cycle 360 angle, twice the intensity of light decreases, twice the intensity is increased for one complete cycle. When the angle is exactly parallel, light coming from the source, intensity is 50%. There would be the vibration. But vibrations decreases when the crystals rotate from 0 degree to the certain angle. So the intensity decreases. Intensity varies from maximum to 0. When intensity decreases maximum to 0, it's a completely plane polarized light. So the given light is completely plane polarized. We can come to conclude, if intensity of light, when the crystal be rotate, intensity decreases at 90 degree exactly a place, crystal B with the A, no light coming out from the source. So the given light is a completely plane polarized. Completely plane polarized. Completely plane polarized. If the completely plane polarized, intensity varies from maximum to 0. So the given light is completely plane polarized. It is a transverse vibration. It's vibrate perpendicular to one another. Perpendicular to one another. So the light, the given light from the source passes through the crystal A, the vibration is restricted. If another crystal is kept exactly perpendicular to the crystal B, the crystal A, no light is coming out. That means intensity becomes 0. That means initially it is kept parallel, the intensity maximum, now reduced to 0. So the given light is a completely plane polarized light. Completely plane polarized. If suppose, if I am rotating the crystal from 90 degrees or 0 degree to 90 degree, intensity decreases. Gradually intensity decreases. When it comes to exactly perpendicular, intensity varies, not equal to 0. The intensity not equal to 0. Not equal to 0, but decreases. But maximum to minimum. Maximum to minimum. Not equal, not coming to the 0. So when the crystals rotate from 0 degree to 90 degree, intensity light coming from the A reduce. One stage becomes completely stopped. That radiation is called plane polarized beam. Now not completely, still there is some radiation coming out. Even the crystals are kept parallel. So perpendicular to the crystal B. So there is a radiation coming out. Such a light is not, we cannot say that given light is completely plane, that is a partially plane polarized. Partially plane polarized. The intensity of light varies from maximum to minimum, not 0. Such a radiation is not completely plane polarized, that is a partially plane polarized. In another case, if whatever may be the angle rotated by the crystal B with respect to A, it is orientation. There is no change in the intensity of light. There is no change. What intensity is incident on the crystal A, same intensity is emerging out from B. That means what? But the given light is not restricted. The vibration of the light is not restricted. Such a radiation is called unpolarized. No change of intensity. It is unpolarized. So the given light is completely plane polarized or not can be determined when one of the crystal B rotates from 0 angle to 90 degree. If the intensity varies from 0 to 90, the rotations, if we rotate from 0 to 90 degree, the intensity varies from maximum to 0. The given light is incident the crystal is completely plane polarized. If the intensity varies from maximum to minimum, given light is partially plane polarized. If the intensity is not change, the same light, original intensity light can be obtained the crystal B, even though whatever may be the rotation made by the crystal B, no change in the intensity. So such a radiation not plane polarized, unpolarized beam. Unpolarized beam. So the given light is completely plane polarized or not, or partially plane polarized or unpolarized beam can be obtained. How could we determine with the help of analyzer polarizer? So polarizer. Polarizer and analyzer. What is a polarizer? Polarizer is used to produce a plane polarized beam. Polarizer is used to produce a plane polarized beam. So the given light is incident on the crystal A. Light is emerging. Light is emerging. So this given radiation is complete. That is a polarized beam. So given light is polarized by the crystal. So this is called a polarizer. This is called a polarizer. Now the given light is a complete. So this is a polarizer. If the given light is a completely plane polarized or not, how to conclude? By using the analyzer. This is the analyzer. The crystal B, the polarizer, we are not rotating the polarizer. Only the analyzers, by rotating the analyzer, we can come to conclude the given light is a completely plane polarized or not. Completely plane polarized or not. So the generally how could we distinguish the given light is past the polarized or not? So the vibration restricting. So the unpolarized beam of unpolarized ordinary light. Ordinary light vibration consists all direction. All direction. If we insert on the crystal, so vibration restricting. So the phenomenon of restrictive vibration into only one plane is called plane polarized or polarization. So the polarization means restricting vibration to only one plane. So such a phenomenon called polarization. So all the radiation into only one direction. That is called a polarizer. Polarization means only one direction, not all direction. So the contain all direction. So the vibration restricted to only one direction. Restricted. So another restricted vibration can be mentioned like this dot. This is also polarizer, but this is vibration. So vibration, see these radiation which are perpendicular to the crystal completely restricted, mentioned by the dot. So both are plane polarized. Both are plane polarized. Both are plane polarized. So vibrations into only one plane. A vibration restricted into only one plane is called polarization. Suppose this is the crystal. This is a tourmaline crystal. It is a natural crystal which vibration restricted to only one plane. Restricted into one plane. If unpolarized light passes through the crystal, unpolarized light, because I can write like this, because all electric vector component can be converted into two components. One is parallel component, another one is perpendicular component. So this is also unpolarized beam passes through the crystal. So the vibration restricted only one direction. So that is a direction of the propagation. A, B, C, D. This plane, the plane A, B, C contain the vibration. So this is called plane of vibration. This is called the plane of vibration. This plane, this is called the plane of polarization. This is the direction of the propagation. Direction of the propagation. So the plane which contains the vibration is called the plane of vibration. The plane which has no vibration is called plane of polarization. So the PQRS, A, B, C, D plane vibration contain. vibration. PQRS plane, no vibration. No vibration. The plane which contains the vibration is called plane of vibration. This is plane of polarization. The plane which contains the vibration is called a plane of vibration. The plane which has no vibration is called the plane of polarization. Here, plane of vibration, plane of polarization perpendicular to one another. This is the plane of vibration, this is the plane of polarization. So, both the plane are perpendicular to one another. Plane of vibration perpendicular to the direction of propagation. Plane of polarization parallel to the direction of propagation. So the angle between plane of vibration and the plane of polarization is 90 degree. 90 degree. The angle between plane of vibration and propagation is also 90 degree. The angle between plane of vibration and the direction of the propagation 90 degree. The angle between plane of vibration, plane of polarization also 90 degree. But the angle between plane of polarization and the plane of the direction of the propagation, that is a zero angle. So it is crystal, light transmitting, so the direction of the propagation. It's a crystal, it's the direction of the propagation. Now the plane contains the vibration is called the plane of polarization. So the plane of polarization, direction of propagation 90 degree. Now the plane which has no vibration is called the plane of polarization. Now the plane of polarization along the direction of propagation. So the angle between plane of polarization and the plane of vibration 90 degree. Angle between plane of vibration, direction of propagation 90 degree. The angle between plane of polarization, propagation of light is 0 degree. So polarization means a restricted vibration into only one plane. Restricted vibration into one plane. So the vibration consists of all direction. Ordinarily it consists of direction, vibration all direction. But vibration of the light restricted only one direction. Only one direction. Such a phenomenon is called polarization. So the polarization phenomena can be observed only the light. Why? Light wave is a transverse vibration. We cannot find the light radiation coming from the sound is a completely plane polarized or not, because sound wave is a longitudinal wave. Sound wave is longitudinal wave. So only the phenomena, the polarization which distinguishes the given light is or given radiation is given radiation is a longitudinal vibration or transverse vibration. If any radiation transverse vibration where the vibration is restricted only one direction, so definitely the plane polarizations occur. But the sound wave, we cannot determine polarization phenomena because sound wave is longitudinal wave. Sound wave is longitudinal wave. So there are some technique to produce a plane polarized beam. Some techniques. There are several techniques. One of the technique is the polarization by selective absorption, polarization by reflection, polarization by double refraction, polarization by scattering. So these are the techniques. These are some techniques. There are several techniques to produce a plane polarized beam. So the most importantly we are practically using the four techniques. Only the polarization by selective absorption, polarization by reflection, polarization by double refraction, polarization by scattering. We will see this technique next class. Thank you.